Hello students. So after the study of photoelectric emission experimentally, there are certain laws which are derived, or basically they are given on the basis of experimental results that we get during the photoelectric effect. So we have 4 such laws and we call those laws as laws of photoelectric emission. So the first law is for a given photosensitive metal or a material, the frequency of incident radiation, if that frequency is above the threshold frequency, then the photoelectric current that we are getting is directly proportional to the intensity of light, okay, and the saturation current is directly proportional to the intensity of incident radiation. So the first law that we have is for a photosensitive material. This is for a photosensitive material or a metal. If the frequency of incident radiation nu is more than the threshold frequency, then in this case the photoelectric current that we are getting, photoelectric current is directly proportional to the intensity of that incident light, right? The photoelectric current depends on the intensity of light. Also, the value of saturation current is directly proportional to the intensity of light. So this shows that if we incident high intensity of light, then we get more photoelectric current and the value of saturation current will also be more in that case. So intensity of light is responsible for the photoelectric current and saturation value of current. Second law is for a given photosensitive material, there exists a certain minimum cutoff frequency below which no photoelectrons are emitted, however high the intensity is. That we have also concluded in the last video. So however high the intensity of incident radiation, but if the frequency of radiation is less than the certain minimum frequency for that metal, there is no photoelectric emission, and that certain value of frequency below which there is no photoelectric emission is called threshold frequency. So second law is for a photosensitive material, there exists a certain frequency, let it be nu naught. So there exists a certain frequency nu naught such that if incident frequency nu is less than nu naught, if incident frequency nu is less than nu naught, there is no photoelectron emission, or we can't observe photoelectric effect in that case, however high the intensity is. फोटोइलेक्ट्रिक एमिशन होगा या नहीं, दैट डिपेंड्स ऑन द फ्रीक्वेंसी, और फोटोइलेक्ट्रिक इफेक्ट में कितने फोटो इलेक्ट्रॉन्स निकलेंगे, एमिट होंगे, दैट विल डिपेंड ऑन इंटेंसिटी ऑफ दैट लाइट. सो हेयर we are talking about whether photoelectron emission take place or not. So frequency is responsible for that, and below this frequency nu naught there is no photoelectron emission, and we call this frequency as threshold frequency. This is known as threshold frequency. So this is the second law of photoelectric emission. Now third law of photoelectric emission is above the threshold frequency, the stopping potential or the maximum kinetic energy, that means the kinetic energy of the fastest moving photoelectron, is directly proportional to the frequency of incident radiation but is independent of intensity. That means we are talking about the situation above threshold frequency. Since the frequency of incident radiation is above threshold frequency, that means photoelectric electrons are emitted here Means in this situation photoelectric emission is happening. Now photoelectric emission is taking place, but in this situation the stopping potential or the maximum kinetic energy or the kinetic energy of the fastest moving photoelectron, both these factors directly depends on the frequency of the incident radiation, that is nu. Why it depends? Because if nu is more, if the frequency of incident radiation is high, the photoelectrons that we are getting are of more energy, right? The photoelectrons are of more energy, and that's why we need more stopping potential to stop those photoelectrons that are moving towards the anode. But this factor stopping potential is directly proportional to the frequency of incident radiation but is independent of intensity. It doesn't depend on intensity, it only depends on the frequency of the incident radiation. This is the third law. Now moving to the fourth law. Fourth law is photoelectric emission is an instantaneous process. That means the time lag between the incidence of light radiation I should say, and the emission of photoelectron is very small. It is approximately about or even less than 10 to the power minus 9 seconds, which we can't observe. So it seems to us that the process is happening instantaneously. That's why we call the process of photoelectric emission is instantaneous, right? So photoelectric emission is an instantaneous process because the time lag between incidence of light and emission of photoelectron is even less than 10 to the power minus 9 seconds. So it seems to be happen instantaneously to us. That's why we call it as instantaneous process. So these four are the laws of photoelectric emission that we derive from the experimental study of photoelectric effect. That's all for the video. For further videos, stay tuned and keep studying. Thank you.